So, first of all, understanding the process of solar plant designing, we need to understand why the software we needed for the solar plant design. So, first of all, for solar plant, if we consider any kind of drawing and design, the most challenging thing for solar plant is the shadow analysis or the impact of shadow. So that is very important because when shadow comes to the solar module stops working and it can also derate the overall efficiency of the module. So for this reason, we have to design our plant in such a way so that the shadow impact is also neglected and we can get the maximum generation out of the plant. Okay. Next point is, we all know that when we are putting up the solar plant, we are actually promoting renewable energy, right? We are actually investing on the renewable energy part. Now, in renewable energy, rather than the renewable energy investment with a solar plant, I can also save a huge amount of money. How it can be possible? Because when you install solar system in your rooftop or in your premises, actually you are using your own consumption through the solar plant. So in that case, you are no longer dependent on the electricity line or electricity department. So in that case, you are actually saving a amount through the electricity bill. So that's why when I am investing some amount for a solar project, so actually I am going to get that money back after a certain time period. So that is where we call it as ROI, return on investment. So how much amount I have invested for any project, so I'll get it returned through the electricity savings. Now the point has come up, where the software plays a role here. Now this software plays a vital role for this ROI calculation, because when I am investing something on solar plant, so I need to know that yearly how much amount I can save from a plant, like by using a solar plant, how much electricity actually I am saving. So that only can be analyzed through this software, because inside this software we have a certain like criteria that throughout a certain year with a specific solar module or with a specific solar inverter, how much energy I can generate through the solar plant. So with a certain year, how much energy I can get from a solar plant with a certain capacity, that can be easily analyzed through the software. And with the generation data, I can analyze, okay, this much of money I can save. So through this, I can get the ROI, which generally for solar project, which is nearby 3 to 4 years. It varies according to the location, according to the system what you are using. So this is the basic purpose. And another purpose which where PVSyst plays a vital role, which is like, if I say that in solar industry, there are lots of different kind of manufacturer of solar module, solar inverter. So when you are installing a plant, you might be confused, okay, which combination I should consider, which module or which inverter I should consider. So where PVSyst plays a vital role, because with this software, with a certain module, let's say you have a module make of A module and B inverter. So in that case, what happens, like with a certain make, different kind of make, you can analyze the generation. Okay, with which combination is best for your particular purpose, for your requirement. So that calculation is also very easily you can get it from the software. Now let's come to the software first. Okay, so now first of all, in solar field, uh, there are basically three types of solar project, or we can say that there are three types of designing concept we can incorporate in the software, or three type of system we can design in the software. First one is that grid connected system. Grid connected means, as we all know that solar system, when we talk about renewable energy or solar system, it always dependent on the weather, the radiation of the solar, the wind speed, the temperature of the particular location. So there are lots of weather parameter involved in it. So it's not dependent on any other like external pressure or external like fossil fuel generation. So that's why solar cannot be like single source of power. It's not possible that you totally dependent on solar system. It's not possible. Solar is always need a backup, and that backup sometimes we in a certain industry, like the current scenario, we use solar inverter with grid connection. Grid connection means you are connecting your solar inverter with a electricity connection. Let me show you that diagram. Basically, solar plant is having three types. One is on grid. That means here the solar system will support it through grid. Grid means the electricity connection from the discom, from the state authority or the discom which is available in that specific location. So here with the solar, grid will be the support. That means during the night hours, when the sun is not available, that time you will take the power from the electricity. Next point is that there is another type of system which is called off grid. Okay. Now, what is off grid? Off grid is also just like the same concept with on grid, but here grid will not connected. Here, instead of grid, that means the instead of electricity connection, we will have battery. That means solar will be definitely there, but as a support or as a backup, the battery will be there. And there is another type of system which we can't design in PVC software, that is called hybrid system. Now, hybrid system means here battery, grid, and like battery, grid, and solar. Hybrid always doesn't mean that battery, grid, and solar will be there. Hybrid means that rather than the solar, there will be a multiple source of energy which can back up your solar plant. Okay, so that is the various type of solar system. So in PVC software, we can design only these two type of system: on grid and off grid. Okay, and there is another type of system, that is pumping, solar pumping system. This is generally used for the irrigation purpose, because during the farming season, like during summer season, always we have the problem with the water. So that's why nowadays people using a solar system in their farming land, and they are just taking water, groundwater, using the solar power. That is called solar irrigation system or solar pumping system. So that is also we can design through the PVSyst software. Okay. Now, just a minute. Another thing I need to confirm you here, that for every type of solar module and solar inverter, there will be a certain specific file is also there, that is called PAN file and OND file. This is basically applicable for a certain inverter. All the technical data and certain module, all the technical data will be feed it to the software. It's basically in a broader manner. You have to understand this. Now, today I will just try to explain you about the process of the designing for on-grid system. Okay, how you can create a new project, how you can consider the parameters for a certain designing. So that things I will try to explain here. So first of all, this is a project what I have already done, but we are going to go for a new one. So let's say I am going to create a new project. Okay. So in that case, what you will do, first of all, you can go for this. First of all, you can go with this grid connected system, right? We are going for a grid connected system. So you can click on this. If you have any previous project, then this window will come up, that last project what you have done. Otherwise, you can go with this option, new project. When you just click on this option, so the new project window will come up. Okay, this is the new project window. Now here you can consider the name of the project. Let me just open up any of the site so that we can consider it accordingly. So you can see with this drawing, it's a project it's in Delhi. So it's a project. So where we have considered these number of modules for this particular project. It's in Chhatarpur RSS. So here with this particular project, we are trying to create a PVSyst report. We already done the survey and we already put up the modules here. So we know that a certain amount of module can be placed here, and the capacity can be possible for this particular area, which is 46.44, where the PV module capacity is 540 watt peak. Okay, so with this thing, I'll consider all the parameters. Now here, first of all, to design any of the site, the first thing what you need, which is the location. Location means the latitude and longitude of that particular location where you want to plant, like install the solar plant. So I'm just going to copy this thing and go to the Google Maps. And try to paste that location what we have considered. So here you can see that particular location has come up. So we have installed the plant in this building. So I am considering, so to take the latitude longitude of any location, you can go to the Google Maps and you can right click over the location where you want to just from where you want to take the data. Okay. Right now the screen is visible for everyone. Okay. Okay. So now I'm just taking the latitude and longitude from this location. So right click over there, and the first thing you will what you will show. This is hello.
Sorry to disturb you, but the screen is only been shared, not the Google Maps. Yes. shared only the PVSyst window. You can reshare the screen with the option of whole screen.
Sorry, I got disconnected. Just a minute. Now the screen is visible to everyone.
Yes, sir.
Okay. So first of all, in Google Maps, if you go to the Google Maps to if you want to capture the latitude and longitude, you can just right click over there, and the first thing will come up. This is basically the latitude longitude. So you have to just click on it. It will automatically copy it. Now I'm coming to the software first. So here I am going to give a name for this particular project, like it's Chhatarpur RSS. So I'm just giving the name as Chhatarpur RSS. Now, project name has been given. Now you have to create a site file. You can see here, site file. What does it mean? Site file means, as I already told you, that solar plant generation or solar plant is totally dependent on the weather. The solar radiation, temperature of that particular location, the pollution level, that means the air mass value of that particular location. So there are lots of weather parameters involved in it. Now, this software, what the software will do, when I will consider this particular latitude longitude inside this software, the software will take a past year data, past few years data. It's 10 years data. The software will take from their database, and it will analyze the data along with the inverter and module what you have considered, and it will give you the report. So that means basically I have to create a site file to consider all the weather data from their database. Okay, so let me just tell you how to do it. So first of all, here you can see that there are few options is available. So we have to consider this.
Hello.
Yeah.
Sir, I don't think the PVSyst software is visible on your screen.
Okay, just a minute. This problem, why this problem is happening? Just a minute, just a minute. I think here problem is happening. Okay, now it's visible.
Yes, sir, it's visible.
Okay, sorry. Yeah, so I'm just giving you that idea. Okay, first of all, project name, as I told you, that Chhatarpur RSS, that project name what I am considering, that I am giving you. Okay. Next thing is that site file. Site file, as I told you, that I have to create a weather related file or the weather file for this particular database. So to create that, what I will do here in this green plus button, you have to just click on it. So it will create a another window. It will open up another window. It takes time actually. Yeah, this is called geographical site parameters. That means here I will consider the latitude, longitude of that location, what I have considered. Let me just copy this thing, right click, copy it, and here paste it and search for it. So it will take you to that particular area. You can see that actual New Delhi location, it has been come up automatically. The locality, like which locality that particular location is there, country, latitude, longitude, altitude, and the time zone. So there are few parameters automatically software selected. Now you have to click on this accept selected point. So when you just click on this, it will come up to this geographical coordinates parameter. So here you can see that site name has been automatically decided, but you can change it. I am changing it to Chhatarpur. And here you can see that there are different databases available. As I already told you that weather data, there are different weather data the software will consider. So there are different databases also there, but metronome data is like the first one is having a certain amount of accuracy in the data. So we will consider this one only. So now you have to click on import. So when you click on import, the software will automatically grab this last few years data of that particular location from this metronome database, and it will create a, you can see that it's totally coming to this monthly meteo parameter tab. Okay, now here these are the details what we need to understand that generation. So first of all, after coming to this page, you have to consider the irradiation units. First one, kilowatt hour per meter square per day. Basically when it come up, always it come up with kilowatt hour per meter square per month, but we want to take the data daily basis. So that's why daily the global horizontal radiation, like on the horizontal surface, how the solar radiation is come up, how much radiation is diffusing through the surface and the clouds on that particular location, how the temperature is there for this particular location, how the wind velocity is there. There are humidity is there, link turbidity. Link turbidity is basically meaning that how much pollution is available with the air on that particular location. So these are the weather parameter we have already generated. Now what we will do, so you have to click on OK to create the new file. Okay, so I'm just click on OK. So when you click on OK, it will automatically create a site file or the geographical site file. So you can save it. Now you can see that the geographical site file is now saved in the database. Right, now click on OK. Again, there will be a data generation. You can see a synthetic hourly meteo file has also been generated. It means that we kept those data in monthly basis, but when we take those data in software will segregate it in like hourly basis as well. So that is totally a software background job. We have nothing to do with it. Now I have created the site file, I have created the project file. Okay, now next thing what I have to do, you can see that select the meteo file and save the project. So we have already selected that meteo file. It's already saved. Now we have to save the project. Here the save button is available. So you have to save the project here. Right? Now I have saved the project. Now next thing is that software is suggesting you to choose the orientation. But before going to the orientation, we have to consider few parameters also, which is project settings. Like in your certain project, there are few parameters you have to consider. So here lots of things available, but I am just trying to brief the main parameter what we have to consider here. When we consider a solar plant, when we talking about the solar plant, so solar means we always think that, okay, the solar radiation will come up to the solar cell and solar cell will convert that solar radiation into electrical energy. This is the basic concept. Okay, but rather than this part, there is another very important factor involved in it, which is the temperature. Because the solar cell always works within a certain temperature limit. Okay, if the temperature crosses that particular limit or that particular range, so the efficiency of the module and the output will be definitely decreases accordingly. So what we have to do, we have to consider the temperature accordingly. So in solar plant, we have to consider two main temperature parameter. One is what is the lowest temperature for that particular location, the minimum temperature, and what is the highest temperature for that particular location. To get these details, what we can do, there is a website called Time and Date. So through that website, we generally take the data. So this is time and date. Now here you can place that location what you have, and you can click on enter, and here you will get this thing, all the year temperature and all the details. You can get it from this yesterday or past weather option. So let's say I want to know the minimum temperature. That means I am trying to understand, okay, December 2021 for that particular location. Okay, you can see that here the temperature is 4 degrees at 5:30 a.m. At 5:30 a.m. you can see this 4 degrees centigrade lowest temperature. And the website is, again repeating it, the website is timeanddate.com. Timeanddate.com. Okay, this is the website. So here you can get the highest temperature and lowest temperature. Now the screen is visible to everyone. Okay, so this is the lowest temperature. Now to get the highest temperature, you can just go to the April-May month. You can get the highest temperature. 43 degrees. Okay, so what I will do here now, I'll come to the software. Let me share the screen as well. So here you can see that there are lower temperature for absolute voltage limit. That means here you have to, okay, I'm repeating it. So in this time and date software website, you have to take the minimum and maximum temperature details. You can get it from here only. I'm just sharing. In the time and date website, there will be, you have to just paste the location what you have. You can just search for it, and then here you can select the month, the winter season, and also the summer season, so that you can get the idea of the minimum temperature. You can see that here 13th May, this is the minimum temperature, this is the maximum temperature, 15th May. Okay, so this way you can get the minimum and maximum temperature. Now you have to come to the software first, and here you have to mention the minimum and maximum temperature. So I am considering minimum temperature as 5 degree, and the maximum temperature I am just giving it as default 50 degree and 60 degree. Okay, I'm just leaving it as default what the software have already considered, and leave the other parameter as same what the software suggested. Okay, so nothing need to be changed here. You have to change the lower temperature and the higher temperature only. Now click on OK. Okay, so now let me come to the software again. So now you can see that here I have updated the project settings and software now suggesting me to save the project. So I am just saving the project. Again, I already saved the project. Next thing you can see, find here, there is an option called variant. Variant means, as I already told you, that there are lots of different manufacturer of inverter and module. So I want to know the combination, which combination is best for me. So to know that, I want to know, okay, the best module and best inverter and local module and local inverter. I want to know that variation. So you can choose that, okay, I am considering 3 polycrystalline 330 watt peak module and the other things. So that thing you can consider, but I am going to consider here monocrystalline and on-grid inverter. So I am just giving a name on this particular way. If you want to create another combination, then you can just click on new, then another variant will come up. Okay. Now, first thing, orientation. So now, how does orientation relate to solar plant? Anyone having any idea what is tilt angle or why the tilt angle is needed for solar plant? Any idea? You can just type it on chat box or you can unmute yourself. Any idea about the tilt angle and why the tilt angle is needed for solar plant? Okay, let me tell you. First thing is that in solar plant, there is 2 parameters during the module installation we have to consider. One is plane tilt. Another one is azimuth angle. These 2 parameter is very important. So now, first of all, we need to understand what is plane tilt. Plane tilt means when you are placing your solar module with 0 degree, that means your solar module is totally like placed on the ground. So in this case, your optimization of solar radiation will be very less. That means you will lose a huge amount of energy, like the solar radiation, because you have totally horizontally placed the module. Okay, so there is no space between the module and ground, and also the radiation which is receiving on the solar module, the solar radiation which is receiving on the module, it will be less. But if I give an angle here, let's say 30 degree, then what will happen? Instead of going to the ground, it will directly come to the solar module. Okay, before going to the ground. So that means in this case, I will get extra generation. I will get extra generation, right? So I'll gain the solar radiation due to the tilt angle. Now, the main question can be come up here. What will be the tilt angle? How I can consider the tilt angle that, okay, 30 degree or 40 degree or 20 degree, 15 degree, 10 degree, what will be the angle for a certain plant? How can I decide that? To decide this thing, you have to use this software and use this particular portion to understand that concept. So here you can see there is a option yearly meteor yield. It means that how much global radiation is coming up. Here you can see 2014 kilowatt hour per meter square with 30 degree tilt angle. Now I am trying to decrease this and I'll try to analyze this. Okay, at which angle this global on collector plane, this value is maximum. I'm trying to understand that point. Yes, latitude and equivalent is very precisely, it's fine, but always latitude equals to tilt angle. It's not always a certain process. You can consider latitude angle as your tilt angle, but this optimization So sorry, it got disconnected. So here you can see that this 28 degree, at 28 degree angle, the global on collector plane, this particular value is maximum at 28 degree panel tilt. Now let's come to that concept. Okay, latitude angle or ye same. So yes, you can see that it is latitude angle is 28.5 and the tilt angle, the optimum tilt angle, we called it as optimum tilt angle, is coming up 28 degree. Okay, fine. Now this way we have to consider the things, right? Now, so this is the panel tilt. I understand. Let me open up the drawing now. So here you can see in this drawing that I have placed the module, solar module, towards the true south direction. That means this way. This is the south direction. This is south. This is north. Right? That means here the azimuth angle will be 0 degree because I have placed the solar module exactly on the true south direction. But let me open up other drawing. Here you can see that in this case, the true south direction is this way. And I think you are not being able to see this. So here you can see that I have placed the module according to the building is oriented. That means here the azimuth angle is basically, if I draw a line from this point, the angle between this south line to the building oriented line, this angle is basically the azimuth angle. It means that actually it meaning that, let's say if you have a, if this is the north south line and this is east west. Now if the solar if the building is oriented this way, that means it's not towards the south, it's actually towards the southwest direction, right? So if I place the module this way with the solar, like with the building is oriented, then the building azimuth angle will be the azimuth angle of the solar plant as well. Here you can see the azimuth angle is 25 degree. Now, if I consider azimuth angle for any project, I will lose some of the energy. That means, let's say here I am considering azimuth angle as 25 degree. So now what will happen? You can see that here you can see I will lose the generation of 1.3%. Okay. And azimuth angle will become positive if the orientation of your solar module towards southwest direction, then it will be positive. And if it is in southeast, then it will be negative. Okay, this is the southeast direction. Your plant is oriented towards the southeast direction, then it will be negative. So this thing is come up. Let me clarify this thing also. let's say this is north south line, okay, and this is east west line. Now you have a building oriented this way. If I draw middle line from that building, so that building is having an angle with the north south line. This angle is known as azimuth. Okay, and when the orientation of the building towards southwest, then the azimuth will be positive. Okay, and if it is otherwise, like in this way, southeast, then the value will be negative. Okay, clockwise and anti-clockwise concept, simple. So here, according to the project, I don't have any azimuth angle here. So what I will do, I will consider the plane tilt as 28 degree and azimuth angle as 0 degree, because I am placing the solar module towards the exact south direction according to our drawing. Now considering OK. So when you click on OK, your orientation part will complete it. Okay, now we will come to the system part. This is very useful and very important for solar plant designing. Now the designing aspect is coming up, because for every solar module and every solar inverter, it's a electrical parameter related thing. So always the compatibility of the solar module and inverter is very important, because it's not like that you can connect anything to the solar inverter. You have to maintain a certain range of module, certain range of string connections. These things you have to maintain. To maintain this thing, we use this particular tab, or you can say that this is very helpful for that calculation. Now, why this thing is needed? Try to understand this thing. So let's say I have a solar module which is having voltage 40 volt, and I have an inverter which is having input DC voltage. Input DC voltage means anyone can tell me what is the role of inverter for solar plant? Anyone? What is the role of solar inverter in solar plant design? What is the role of solar inverter? Anyone? To convert DC to AC. Energy is stored and generated in DC, but used in AC. Very, very well said, Asutosh. That yeah, energy here in this case for on-grid, I'm not storing the energy basically, first of all, because the battery is not there for on-grid. If it is a off-grid system, then the storage part will come up. But definitely for our consumption or daily usage, we never use the DC, because we always use every equipment through AC power, right? So that's why inverter plays a vital role for solar plant, because I am generating power in DC, direct current, and I need to convert it in AC for our consumption. So that's why inverter plays a vital role for conversion of DC to AC. Now, here in the DC side, I will connect solar module, right? And AC side, I will connect load or the electricity line. That means load means the consumption things like light, fan, TV, washing machine. What are the loads you have? You will connect to the AC side of the inverter. Now the point is this DC side, that means the input side of the inverter. This is basically the input part. So this input part, as it's a equipment, so definitely it will have a certain range. You cannot, in every equipment, there must be a rating and must be a range. So you cannot define anything by yourself. So here in the input side, every inverter having a voltage range, or we called it technically absolute voltage limit. In solar plant designing, this is generally come up 1000 volt for normal string inverter. So you have 1000 volt, right? And each module having 40 volt. So how many module you can connect to a single string? Now the string, what is string? String means, when we talk about a solar plant means solar modules are connected in series connection. And this, when the module connected in series, we called it as a string. Okay, now when the multiple number of string connected to a inverter, we called this whole thing a solar array. Solar array. That means when I am connecting solar module in series connection, we called it string. And that string number of module in a single string is totally dependent on the input voltage of the inverter, right? As I told you, 1000 volt. This 1000 volt is the limit. So how many module you can connect in a single string, that you can easily calculate through this formula, 1000 divided by the voltage of the solar module. Okay, so here you can see that it is coming around 25, but it's not actually this way. There are another parameters involved, but this is the basic concept. Okay, so as in this particular concept, rather than this 2 voltage limit, their temperature is also involved. So this whole thing software does automatically. That's why I have put it the temperature in project settings part. Okay, now come to the software. So here you can see that, first of all, here in the above part, you will have a pre-sizing help button. So here, if you already done the design, you know that how many module can be placed. So you can consider enter planned power. That means you can just click on it and you can consider the planned power. Planned power means what is the capacity of the plant, what you have decided. So according to my drawing, the planned power is 46.44 kilowatt. .44 kilowatt peak. Okay, never go with the area. Most of the people during the design in PVSyst, they're having a wrong concept that they will put up the area, available area, and software will automatically tell you the capacity. But that is wrong, because here in this software is considering only the module area, solar module area. But during the installation of solar module, you no need only the module area, because when you are giving an angle to the solar module, so there must be a certain gap you have to maintain between each module. So that means it's not like only module will be there. There will be a certain external gap also involved in it. So That's why this part is always being neglected. You should not consider this thing. This is wrong. Okay. Now, here you can see that select PV module, like which module make you want to consider here. So let's say I am considering any other brand like Vikram Solar or Rene Solar. So let me consider the Sova Solar one, because here I have considered 540 watt peak module. So 540 I have Sova with. So here you can see that every make module having this detail. So this file you have to generate or you have to collect it from the manufacturer. This file name is called PAN file. According to the PAN file, this all the detailing will come up. Okay, so here you can see that 540 is there. So 540 I'm considering here. And as I have, okay, I have to mention again 46.44, right? Okay, 46.44 I have considered. 540 is the capacity. And as the inverter 46 is the capacity, so I have to consider the inverter with 50 kilowatt rating. Okay, so 50 kilowatt inverter I have considered, right? Now here two option has come up always, multi MPPT feature and number of inverter. Multi MPPT is basically a feature in every inverter is having right now. MPPT feature. MPPT means maximum power point tracking. It means that every string having a different power during the practical scenario. So this MPPT feature will track the maximum power from each string. That means your overall output from the solar plant will be better if your inverter is having MPPT. Nowadays, every inverter having MPPT. So I am considering only single inverter here of 50 kilowatt. Now you can see that according to the consideration of solar module and solar inverter, the software is automatically decided the string. Means 17 module should be in series and 5 strings will be there. So this suggestion is automatically done by the software. So this is the most visible thing with this software, that you no need to calculate it by yourself. Software will automatically tell you that, okay, what is going to be the string and all the detailing. Right, you can see that 5 strings of 17 module for 85 module. Capacity will be 46 kilowatt, 1 MPPT inputs, total 50 kilowatt will be the power. And this is the 28° will be the fixed tilt angle. So all the details has been given here. Now, you can click on, okay, another thing, simplified sketch. Here you can try to understand the concept of solar plant, that this is the PV array, then this is the inverter part. E array means the DC part. E out to the inverter, that means the AC power. Okay, and then here the user will be connected and grid will be connected. When you have the requirement, then directly it will come to the user. When you have the excess energy generation, then it will feed it to the grid through net metering system. Through net metering system, right? So this is the simplified concept. Now I am clicking on OK. So when I am clicking on OK, you can see that one error is coming up. The inverter power is slightly oversized. Why is it showing? Because what I have done here, I have considered 46 kilowatt solar plant with a 50 kilowatt inverter. That means my inverter capacity is higher than the solar module capacity. That's why this error is coming up. But I don't have any other option to do that because with 40 above 40 kilowatt, there is a no inverter. The inverter capacity either 30 kilowatt or 50 kilowatt. There is no inverter of 40 kilowatt or 45 kilowatt. So I have to consider 50 kilowatt. That's why. Okay, now system part is over. Next, the detailed losses parameter will come up. It's a very huge thing. I can't explain step by step. But here, these parameters we always need to be considered. Okay, I am just giving you an idea what are the values should be. So here in this case, I am considering rooftop solar system. So in that case, the first option will be considered. Ohmic losses should be considered default values, like this default value 0.5. This is 1.5. And with the AC cable sizing, here you can consider up to 2.00%, not beyond 2%. Okay, 54 meter will be the cable length. Module LID mismatch, these are the very important losses, and you can consider the default values here. You can see that all the default values have been selected. Then soiling loss. In case of soiling loss means that how the pollution is available with the air and how frequently your solar module is going to be cleaned. So in that case, if the cleaning is planning in frequent basis, then we can consider the default, we can consider 2%. Otherwise, we can consider default value as 3%. IAM losses. This loss is generally happens because of the glass layer in front of solar module. Due to the glass layer, some of the solar radiation always reflects. So that impacts to the solar plant generation. So that is called IAM loss or incidence angle modifier loss. Then auxiliaries is come up. Auxiliary means generally come up with the huge capacity solar plant like 50 megawatt, 100 megawatt solar plant, where there are lots of other equipment is also related to the plant. So those equipment power consumption is generally taken from the solar plant itself. So that's why this is basically a loss. So that auxiliary losses we can consider, but for small plant, it's not necessary. Then aging. Aging means as solar system is a power generating system. It's generating power, right? So when anything comes to the generation, like generating things, it's generating things mean always we have to understand that, okay, if something generating, that means every year there might be a degradation in it. Every year there might be some kind of degradation can be happen. So in solar module, for the first year, there will be a degradation of 2.5%. And after from the second year, the degradation is 0.5%. So it totally varies according to the manufacturer. But here in this case, you can consider the aging only for the first year. Simulation year number 1. Now, if you want to know, okay, at 10th year, when the plant exceeds 10th year, then what will be the generation? Then you can just consider here 10. Then in your report, the generation will come up after the 10 year of simulation. So here in this case, I'm considering the first year only because I need to know that first year generation. Then unavailability will come up. What does this unavailability means? It basically actually relate to the uncertainty factors. Uncertainty factor means the power cut hours. For on-grid solar system, power cut hours is very important because if you have a power cut, then your on-grid inverter will stop working because on-grid inverter take reference voltage and reference current from grid only from the electricity line. So if the electricity line is not available, then your plant won't operate during on-grid system. But with off-grid, that problem is not there. Next thing is that weather condition, like during the cloudy days or cloudy time, rainy days, rainy season, that is also considering as a unavailability factor. That means that factor will be always there. So here in PVCs, that percentage is 2%. So you can consider the default as 2%. I'll just take another 5 minutes, sir, for conclude the session. Just 5 minutes. So I am considering unavailability. Now the spectral correction. Spectral correction means it's basically the different light spectrum involved in solar radiation. So you can consider it, or else you can leave it as well, but you can just select on it. So it will automatically consider monocrystalline or polycrystalline. So you can now click on OK. So now the detail losses part has been completed. Okay. So here other parameter you can leave it. Now you can run the simulation. So when you run the simulation, the software will take all the data, all the consideration I have taken for this particular project. Software will consider all those things. Then it will give you the report. So now you can see this report. You can save it from here, save the document as PDF. You can save it where you want to save it. You can just save it there. Now here you can see that all the details I have considered, everything will come up. That 85 number of solar module I have considered, the capacity of the solar plant, the tilt angle, azimuth angle, the inverter capacity, the generation, the most important thing, the produced energy, which is 73.94 megawatt hour per year for this particular plant. And next, if you come lower part, every detailing what we have considered, everything will be come up here. This is the main table what in PVC software what we generally consider is basically this is the horizontal radiation on the horizontal surface, and then there will be an inclined generation. This is the inclined, that means after giving the tilt angle, that horizontal radiation which is 106, it will come up to 147. That means after giving the angle, I am getting extra, right? And global effective is 141.4. It meaning that there will be a losses of IM losses that I already told you that during the glass layer there must be a loss. So that loss is there. So that's why finally you are getting 141.4 kilowatt hour per meter square of solar radiation to convert it into the electrical energy. So from this you will get this much of electrical energy, 6.064 megawatt hour. Okay, so this way this generation will come up, and in this report you have to check this performance ratio. What is the performance ratio value? Is it above than 75%? The performance ratio of any plant should be above than 75% for the first year. That should be 75%, but here in this case you can see that performance ratio is 80.30%, which is very high and it's feasible. Okay, and this is called loss diagram, like how the losses is happening. So this detailing also you can get. This is all about the report. For more detailing or more detailed understanding, you can just come to my YouTube channel called All About Solar. You can just have a look. Every detailing thing is there only with the PVSyst. Okay, I think I want to conclude it here only. Anyone having any question, you can just ask here.